8th graders. We're here with lesson 6.3 on solving multi-step equations. Now this lesson's great because you're going to get to apply what you've already learned about combining like terms and solving equations. So the first thing you need to know is that in order to solve a multi-step equation, sometimes you have to combine the like terms first. So I'm going to have you do example A by yourself, but first watch me do example B so you know how to do it. And I switched that order because this one's a little bit harder. So negative 15 is by itself. I don't need to do anything there. But here I have 5b and I have a negative 2b. It's very important that I take the sign with whatever number is attached to the variable. So 5b minus 2b is going to give us 3b. And then I have positive 12 plus positive 6. They're both numbers, so they're like terms. 12 plus 6 is 18. And I'm going to say that they equal negative 15. It's okay to switch which side you have your answer on of the equation. So now I get to go ahead and do what I know how to do so well. First, I'm going to undo the addition or subtraction. I'm going to subtract 18 and subtract 18. When I am finding the sum of numbers with the same sign, I find the sum. So 15 plus 18 is 33, and they're going to keep that sign. So 3b equals negative 33. And now I'm going to divide to undo the multiplication. And so b is going to equal negative 11. I can plug this negative 11 back into this problem and work it out using PEMDAS to make sure that I get negative 15. I urge you to do that. All right, there's another way that we can simplify, and that is to use the distributive property. So remember, the distributive property, first we're going to multiply this term times the 2.9. So 5 times 2.9 is 14.5. And then I'm going to bring the sign in the middle down, and then I'm going to multiply 5 times k. And we write that by just writing 5k equals 8.3. Now I would like you to pause the video and solve this equation as you already know how to do, and then you can hit play and see if you solved it the same as I did. How did you do? Did you get negative 1.24? If not, look at my steps and see where you made your mistake. Okay, let's explore what happens with distributive with our tiles. So here I have x plus 1 happening 2 times. And so when I do 2 times x, it's like I'm taking my x's out and putting them together. And then when I add that to my 2 times 1, I take my 2 ones together and I get positive 2. So now I have 2x plus 2. In order to get rid of the thing that's being added or subtracted to my x, I'm going to add 2 negatives. So I'm adding negative 2 here, which gets rid of those. Whatever I do to that side, I need to do to this side. So I add negative 2 there. And now I'm left with 2x equals 10. Now from here I need to split these into 2 equal groups, so I'm going to split this into 2 equal groups, and I'm going to get 2 groups. And now that I have 2 groups, I only want 1 group left, so I'm going to take away 1 group there and take away 1 group here, and I get x equals 5. All right, let's go on to the second page. You can also simplify with division. Now let's take a look at one of these distributive problems using division. And now in the past when we've just had 2 popsicle sticks or 2 x's over here and we wanted to find out what x was, we divided these tiles into 2 equal groups. Well, we're going to be doing kind of the same thing, except for each group is going to represent an x plus 1. So if I split this into 2 equal groups over here, I would have 2 groups of 6, and I'm just going to want to get rid of all the groups except for 1. So I'm going to take away 1 group here, and I'm going to take away 1 group there. And now what I'm left with is I have x plus 1 equals 6. So from here, I'm going to subtract 1 from there, which is the same thing as adding a negative. So that gets rid of that. And I'm going to add a negative here, which gets rid of that. And so now I have x equals 5. So instead of distributing this 5, this whole thing is being multiplied by 5 right now. So I can undo that by dividing this whole thing by 5. And whatever I do to this side of the equation, I have to do to this side. So I could do 8.3 divided by 5. And I would get 2.9 plus k equals 1.66. And now I'm going to subtract, and I get k equals negative 1.24, which was the same thing we got when we used distributive property. So there is that option that you can do it using division. All right, example C. Your class wants to collect 1,200 bottles as a fundraiser. The 24 students collected 34 bottles each the first week. How many bottles more per student must they collect? So we've got 24 students, and we're going to multiply it times the amount of bottles they already collected, which is 34, and the amount of bottles they still have to collect, which is R. Okay, so now that we have that, let's write it out here and let's solve it. 24 times 34 plus R equals 1,200. 24 times 34 is 816. I'm going to take my sign from the middle. 24 times R is 24R equals 1,200. Subtract 816. Subtract 816, and I have 24R equals 384. Divide by 24, divide by 24, and I get R equals 16. So that means that each student must still bring in 16 bottles. I can check this answer by putting it back into my original and making sure that I get 1,200. All right, for example D, I want you to try this on your own, okay? I am going to give you a little bit of a hint to kind of get you going. So we have your class goes to Seabreeze. The admission is $10 for each student, okay? So we've got $10 for each student and $15 for each of the 6 chaperones. Times your chaperones. So they told you the number of chaperones there. Okay? And it says that the total is 380. So we know the total goes there. There are 12 girls in class. How many boys are there? So the amount of girls plus the amount of boys are going to be our total students that we will want to multiply times 10. And the total chaperones were already told to us that you'll multiply times 15. So this is a hint for how to set up your equation. There's some things missing here that I want you to try to fill in and solve it and bring it to class with you tomorrow. All right, so go ahead and get to work.